Hi, I'm Dan from Maptek in the Perth office. Welcome back to the GeologyCore workshop. So far in this series, we've already taken a look at the vein modeler and domain MCF, so in this video, we're going to focus on the implicit modeler. Since we've already covered the domain manager in a previous video in this series, I'm going to start today with a drill hole database that I've already processed through the domain manager, and I'm happy with how my domains have been flagged. In this instance, we're looking at a lead zinc deposit, and our main unit of interest here is this pink LMS unit that you can see most predominantly in my drill holes. So under the modeling ribbon, we've got the implicit model tool here, which we can open up. And first thing I'm going to do is I'm going to just drag my drill holes into the primary data selection. And we're just going to check that the variable to model is using the correct table and field to model, which it is. You can always change it, obviously. And we're going to go and pick our LMS unit that we want to model here. We also want to ensure that the surface in the implicit model is turned on. Otherwise, you won't get a surface. You'll just get an implicit model object, which you can obviously surface later if you want to. We need to define an appropriate triangle size. So I'm going to go with 5 in this case. Obviously, the smaller you go, the more triangles and the longer it takes to process. Next, we're going to go to the control data section, and we'll play around with some of these options and see how they affect the model that we get. And depending on your data and the model that you get out of it, you might want to use this option up here to use downhole survey data for control, which essentially uses the top and bottom of the drill hole, along with survey depths that aren't inside your domain as extra control points. I'll leave this one unticked for now because this data set doesn't really need it. As we saw in the vein modeler video, we've got the same options here for defining how we utilize contact points that are either at the start of our drill hole or the end of a drill hole for the domain that we're going to model. So we'll start by using this option for inside the surface, which is essentially going to ignore these contact points that start and end in our drill hole. You'll see with this particular data set and this model, this has quite a big influence on the model that we get. So we'll sort of come back to that. We'll leave everything else turned off for now, except we're going to turn on the create closed solid option as we want one closed solid. Finally, under the advanced options here, we're going to start with the default setting of a 20% domain overlap ratio. Now, don't get this confused with your modeling domains. It's actually nothing to do with those. So our implicit modeling engine utilizes what's called a partition of unity algorithm, which basically means the modeling region gets split up into smaller areas, solves the implicit functions for each area independently, and then stitches the implicit models for each region back together before surfacing the final model. So this setting defines the amount of overlap in data used between each subregion. So a smaller overlap ratio is faster to process, which is great if you've got lots and lots of data and it's quite continuous, but a larger overlap ratio will provide better continuity between the subregions. So if you find you're getting what look like big steps in your surface with quite a difference, especially towards the edge of the model where there's less data, then it might be a good idea to bump up the overlap ratio to something like 50% and see how you go. The surfacing performance options are independent of this overlap ratio. Basically, once the implicit functions are solved and stitched together, a marching cubes algorithm is used to generate the surface from the solved implicit model. Multi-threading is obviously faster, but sometimes you might see some artifacts in the surface that can be solved by utilizing the single-threaded option. Finally, if you want to dive deeper into why your model looks the way it does, we can save out our signed distance data points and query them and sort of have a look at them. So I might do that just so we can kind of see that. So now we're ready to make a model. So I'm going to hit OK and we're going to get our model. Now, if we have a look at that, now it's not a great model, if I'm honest. Really. So we'll bring up our visibility manager. I'm going to turn my surface off and my drill holes. And under the GeoModel container, we've got a new one here. So I'm going to bring in my data points. And we can make our points bigger by pressing plus on our keyboard. Now we can see all these colors. First thing we can do is we can show a legend and see what we have. So if I right click on one of my points here and query the point attributes, You can see it's highlighted that point, and it's highlighted in the grid for me. So obviously that's a red point that we've highlighted, which has a positive sign distance value, which means that it's outside the surface or outside the solid that we're trying to model. If I select one of my blue data points using the point select mode, you can see it's got a negative sign distance value, right? Our blue ones have negative sign distance values. This means that they're inside the surface. So we'll get rid of those. I don't need my data points now, so we can bring back our drill holes and our surface. So with any surface that's made from the implicit modeler, we can just right click on it and we can say remodel. And this is going to open the implicit model panel with all of the settings that we use to make that particular surface. So we're going to go back to the controlled data panel. The first thing I might want to do is I've got a bounding box here that I want to use, that my model should be inside. So I'm going to pull my bounding box into this surface envelope option here. And then I can just press apply and replace or remodel my surface. So obviously that's chopped out some of the bulge. But the next thing I want to do is I want to use this add extent infill points. So I'm going to set a range of between 40 and 60 meters away from my data. And I want it to create points every 20 meters within that range that I've defined. So if I go ahead and remodel that, you can see that that's made a much more constrained model, which is nice. So get rid of my bounding box. So I'm happier with that. It's starting to look a bit better. So if I make my surface a bit translucent here, we can sort of have a look at how it aligns with our drilling data. So you can see it's bulged out a fair bit sort of around here because of the options we're using here around how we treat contact points that are at the start and the end of the drill holes. So if these drill holes have been terminated by geologists when they hit the end of the domain, for example, then these contact points might be perfectly acceptable to use. So let's change this option to include those as contact points and remodel. So you can see now that's much more constrained by our actual drilling data, which is nice. So we're sort of getting a much better fit to our data by doing it this way. Assuming, of course, in this case, that's what we want to do. So one more thing we might want to do is we might want to apply a bit of a trend to our data here. So to do that, I'm going to use the C key on my keyboard to select a center of rotation. So I might want to put my center of rotation here. Once I've done that, I can go back to the modeling ribbon and I can select on the ellipsoid option here. And that's going to create an ellipsoid where my current center of rotation is. Now I like to define the semi-major at half the major length and the minor at 0.3. So this kind of just gives me a nice anisotropic control. Now to align this in the orientation that I want, I can use my middle mouse button to sort of use these rotation sliders, or these rotation discs, and align it in the orientation that I feel is my data is most continuous. So we might do it a bit like that. And that's not too bad. So I can select OK and it will create that ellipsoid in the GeoModel container for me. Now I can use my middle mouse button and drag that off the screen into the anisotropic control component. And now if we rerun that, you can see my model is a lot more continuous in that orientation and sort of has less holes except for sort of where we expect them to be, really when we've got a different domain. Now if I want some finer control over what the model does in certain areas, I can add additional data like ribbons to control that. So if we find a spot that we want to edit, so I might want to join these two bits up, for example, through here. So to do so, we can just create a line. So I will create my line from there to there. And then we can sort of select a line, go to the edit, and I'm going to use subdivide edge. And this is essentially going to put a bunch of extra points along the line for me, which the implicit modeler is going to love. Once we've done that, then we can go to the modeling tab and we can use this convert to ribbon option, which is going to convert my line to a ribbon. Now this is kind of the underneath of my surface, so I want to make sure that the colored side is on the outside of the surface and the uncolored side is on the inside. So I'm going to select that, I'm going to use edit ribbon, that's going to bring up my manipulators, and then I can just use my middle mouse button to spin the ribbon around to the orientation that I want. So we still want to tweak that a little bit. Maybe something like that. And I can turn off the ribbon edit, right click on my surface, remodel it. I can go to the additional data and I can drag my ribbon in there and then I can reapply. And you can see now that's kind of pulled the model through in that area like I would like it to. So I'm much happier with this model than I was obviously when we started. So that's good. So just as a sort of final bit, we might want to actually, rather than modeling from a domain, we might want to model something like grade. So again, we're in a lead zinc deposit. So I flick to my other legend. So now this time we're going to implicit model a grade cutoff shape. So I grab my drill holes. We're going to go and find our zinc field, and I might use a grade cutoff of 10%. It's going to use a continuous grade option to model this time. Under our control data, I'm going to use similar options to what we used last time. This time I'm going to use the downhole survey data for control. I'm going to use my bounding box. And this time we're going to use a distance to the nearest data point of 50 meters to constrain the model a bit. And we might want to use our ellipsoid from before. So if I do that and sort of rerun it, we can see the impact of that. So in that case, I feel like that's probably a much better shape than what we initially got. So there's a lot of flexibility, a lot of tools in here to help you streamline and get the best results out of your implicit modeling. Next week, we're going to jump back over to New Zealand, where Richard will close out the series with a look at getting your data back out of GeologyCore when you finish modeling. So tune in then to learn about the export and publish to Vulkan tools. Thanks for watching.